All right, let's review together the exam. I don't know how far this video is going to get in terms of how many questions, but as soon as this probably be 2 videos. So here's the first one. How do I find the zeros? I first look to see if it's factorable. They're not in ratio to each other, so we're going to create a list. So that last number, all the numbers that go into 10, create a list. This is the rational zero theorem. Then from that list, I need to test and see which one gives me a 0 at the end. Now, I already know which ones work. You don't, so you would have to pick a number, pick another number until it works. So I'm going to pick 1 and see if it works. If it didn't work, that means you have a 0 at the end if it does work. Then you have to start again and try until you do find one that gives you that 0 at the end. So this is 1x squared, that's plus 7x and plus 10. So when I factor what's left, the two numbers that multiply to 10 and add to 7, the two factors are positive 5 and positive 2. So the 0 that comes from here is negative 5, that's rational. The 0 that comes from here is negative 2, that's rational. And then this number gave me 0, that's it. There are no irrational and no complex zeros, and you found them all. All right, next one. This one is a trinomial. I'm already going to figure out, I'm going to factor. I don't need a list. So what are the two numbers that multiply to 8 and add to negative 6? That's negative 4 and negative 2. Because of x to the fourth, it's going to be x squared minus 4 and x squared minus 2. Then I'm going to take that equal to 0 each one. So I'm going to create two equations and solve them. So for the first one, I'm going to add 4. Then I'm going to square root. I know that means the answer is positive and negative. The square root of 4, what number times itself is 4. So those answers, positive 2 and negative 2, are rational. I'm going to add 2, and then I'm going to square root again. Again, I know the answer is positive and negative. Is there a number times itself that's 2? No. So you keep the square root over it. So positive root 2 and negative root 2 are irrational because we can't take the square root of it. You only estimate it. Complex would mean there'd be an I in the answer. You'd have a negative number you are square rooting. All right, let's keep going. This one is factorable because they're in ratio to each other. So I'm going to factor out x squared. I'm going to factor out a 9. And then recognize one factor is x minus 1 and the other is x squared plus 9. Now this first one, that 0 is positive 1 and it's rational. For the second one, I'm going to make it equal to 0 and solve it. So I'm going to subtract 9. When I square root, again, the answer is positive and negative. The square root of a negative number is imaginary, and the square root of 9 is 3, so it's 3i. And so that's positive 3i and negative 3i, and there are no irrational zeros. So we have a rational 0 at 1 and two irrational complex zeros, or imaginary zeros, at positive 3i and negative 3i. All right, another one we can factor. This one is a difference of squares, or we can create a list if you like. But if I square root x to the fourth and I square root 16, I get x squared and 4. So one is going to be x squared plus 4 and the other is going to be x squared minus 4. Then I take each one, make them equal to 0, and I solve them for my zeros. So on one side I'm going to subtract 4, and when I square root a negative number, the answer is going to be imaginary. And the square root of 4 is 2, both positive and negative. Those are complex, so 2i and negative 2i. On the other side, I'm going to add 4, square root, and again, it's positive and negative, but the square root of a positive number is just 2, so it's positive 2 and negative 2. So we have two rational zeros, and we have two complex zeros. You definitely have to try this first, and then watch the video. Here, these are not in ratio to each other, so I have to create a list. 24 is a beautiful number, but it's frustrating for this because the list is so long. So make sure I didn't leave out a number, but these are all the numbers that go into 24 evenly. And I got to test, and I got to find one that works. And again, there is no shortcut here in terms of it. You got to know and try and see which one gives you 0. So I know, for instance, positive 2 is going to work. 1 did not work, negative 1 did not work. And then as we add and multiply, it does give you 0 at the end. So that's 1x squared and 7x and 12. So if I factor that, That gives me 4 and 3. So I have 4 and I have 3. Now, the zeros for each are the opposite to the factor. That's -4 and -3. They're rational. 2 also worked, not the opposite number there. And we have no irrational, no complex. We found them all. The degree tells you how many we're finding, and we found them all. Oh, this one looks fun. So this is a long one. So all the numbers that go into 27, which isn't a bad number, and then I need to just find that one and see what happens. So we have 1, 3. Remember, I'm aware that if there's an exponent missing, you need to put a 0 there. And then create your columns. 1 and -1 do not work. 3 and -3. I think -3 works. I know it works. Now, what's left over is 1 degree less. So it's 1x to the 4th, no x to the 3. 10x squared, no x, 9, and then I'm going to factor that. So I'm going to do a diamond, two numbers that multiply to 9 and add to 10. That's 1 and 9. So I have x squared plus 1 and x squared plus 9. So each one I'm going to make equal to 0 and solve it. Remember at the end, how many zeros am I going to find is 5. I already know one, -3, that's rational. That's a 0. So if I solve this, I'm going to subtract 1. When I square root a negative number, it's imaginary. So that's positive I and negative I. So the square root of -1 is I and negative I. If I subtract 9 and square root, the square root of a negative number again is imaginary, and the square root of 9 is 3. So it's positive 3i and negative 3i. And if I go 1, 2, 3, 4, 5, that's all the zeros. All right, next one is an HP one. So if you're not an HP, skip it. All right. We need this. These are not in ratio to each other, but it's an easy list: 1, 2, and 4. And then I'm going to make sure there's no missing powers. And then I have to try. So again, I know. Sorry, -2 works. 1 doesn't work. -1 doesn't work. 2 doesn't work. So -2 works. And then what's left over is x squared plus 4x minus 2. Not factorial, not diamonds. Instead, we're going to complete the square. So I'm going to take that b value, divide by 2, and square it. So 4 divided by 2, 2 squared, that number is 4. Haha. So I'm going to add 4 to the right and left. And then I'm going to solve it. So if I factor what's inside the parentheses, that is a diamond. What two numbers multiply to 4 and add to 4? That's 2 and 2. That's squared instead of 2 and 2. I'm going to add 2 to both sides. That's 6. Then I'm going to square root. So we have x plus 2 plus and minus the square root of 6. Subtract 2, and you have your answer. Those are irrational. So -2, not I. So -2 plus root 6, -2 minus root 6. Oh, and -2 is rational. And those are your 3 zeros. No complex. All right, last one here, just like this. There are too many terms, so I got to do a list. So again, 24, we did that up there. So I'm just going to copy what I did. So 3, 4, 6, 8, 12, 24. All right, again, you'd have to guess. I know, so it's not fair. Which one works? But one works. So let's see if I can. So that gives you 0. Then I got to do it again because they're not in ratio to each other. So I need to find another number on the list. 2 actually works. What did I do wrong? -7. Let's get our signs right. And that's 12, and that's 24. All right, so that gives you 0. So that's x squared minus 7x plus 12. That's a diamond. So two numbers that multiply to 12 and -7. That's -4 and -3. And then we write them down, what they are. So those are factors. So the opposite numbers, +4, +3, +2, +1. Hey, look at that. 1, 2, 3, 4. No irrational, no complex. And we found 4 zeros, and we found them. All right, turn the page. How about division? How do I know if it's long or synthetic? It's the first number in front of x that you're dividing, the divisor. See, that's 1. Like if it's just x plus or minus a number, that's synthetic. If it's a number other than 1 in front, so like 3x, that's long division. 4x, that's long division. So if it's just x with a number, it's synthetic. The opposite number is 8. Be careful if something's missing, like here, 3, negative 25, 0x, and 67. So be aware of missing exponents. Drop down the 3, multiply, and you have your answer. So the answer would be, I'll do it right here, 3x, this is not your answer yet. So 3x squared minus 1x minus 8, and then the remainder is positive, and it's 3 over what I divided by x minus 8. Now it's over. Right, let's try this again. So x plus 5, synthetic. So the opposite number, that's 4 missing, negative 92 missing, negative 205. All right. Oh, there's a bell there. So I know my time's coming to an end, but I'll do another video. So drop down the 4, that's negative 20. That's positive 100. That's 8, that's negative 40. 5 times negative times the negative, 5 times 40, that's 200. That's negative 5. So how do I write this answer? So x to the 4th, 1 degree less. So this is going to be 4x to the 3, then count down. That's negative 20x squared, count down. That's plus positive 8x, count down. That's minus 40, count down. That's the remainder at the end. So usually I try to box that. So that's negative, so it's subtract 5 over what I divided by x plus 5. All right, long division. And I think this page will be it. Then I'll do another video. You still have to be careful of missing powers. So long division, we just do the power term over the power term. So I'm going to go 9x cubed divided by 3x. So that gives me 3x squared. Then I take that answer, 3x squared, and I multiply it times 3x minus 1. So I'm just going to take the answer, put it right in. So first of all, on top is 3x squared. Then 3x squared times 3x is 9x cubed. 3x squared times negative 1 is negative 3x squared. Subtract. Be careful. When you subtract a negative, it makes it adding. So that's why it's 9. Bring down the next number and do it again. So the next one is 9x squared divided by 3x. So 9 divided by 3 and x squared divided by x. That gives me 3x. Then I take that answer, 3x, and I multiply it by 3x minus 1. Again, distribute. That's 9x squared, and then 3x times negative 1. Then that answer goes here. So 9x squared minus 3x. Again, be careful of subtracting. When you subtract a negative, that means you're adding. So this is really adding. That's 6. Bring down the 5, and then we're almost done. I'll do that over here. So we have 6x divided by 3x. So 6 divided by 3, the x's cross out. Then take that 2 and we multiply and distribute. That's 6x minus 2. And then subtract. Again, when you subtract a negative, you're adding. That's 7. And then how do I write that answer at the end? So this answer was 2. And then the remainder is 7, which is a fraction, over 3x minus 1. You need to try it first. So again, long division, you can't do synthetic because of that 4. Start first. Power over power. Just those. So 8x squared divided by 4x. So 8 divided by 4, and then x squared divided by x. Subtract the exponents. That's 2x. Then take 2x and multiply it by 4x. Take away 3. So multiply. That's 8x squared. Multiply again. That's minus 6x. Be careful when you subtract a negative, means you're adding. Bring down the last number. Again, we're going to divide. I'll do that here. 12x divided by 4x. 12 divided by 4. The x's cross out. It's just 3. Take the answer 3 and we multiply it with 4x. Take away 3. Again, multiply. That's 12x. Again, multiply. That's negative 9. When I subtract this, subtracting a negative means you're adding. So negative 5 plus 9. We have 4 more positives. So we go plus 4 over the divisor. Done. All right, I'm just going to keep going until I hear the bell. Remainder theorem. is synthetic substitution, a new way to be able to evaluate a function by dividing. So I want to evaluate at 7. So I use 7, not the opposite number, and I divide into this 5, negative 40, 37, and 18, no missing powers. And then be careful, drop the 5 down. What's 7 times 5? And then add the numbers. What's 7 times negative 5? Then add the numbers. What's 7 times 2? Add the numbers. And then that last number is my answer. Again, evaluate at 9. So a new way to evaluate by dividing. So we have 8, we have minus 75, we have 28, 0, because we're missing x, and negative 97. Drop the 8 down, that's 72. I'm just multiplying, that's negative 27, that's 1. 9 times 1, add 9 times 9, and then add at the end, and the answer is negative 16. So we're doing all of this to get the remainder is what the answer is when you evaluate. All right, the factor theorem is similar. If I give you a factor, do the opposite number, which is 5. And then we know the remainder at the end is going to be 0 because it's a factor. So we drop down the 2 and we multiply it out. This is what, 75? What is that? 25, 3, is that 18? That's 90. I can do it. Then I have 2x squared, 15x, and 18. All right. So the first number times the last number is 36. And 15 underneath. Two numbers that multiply to 36 and add to 15. Not 9 and 4, not 6 and 6. I'm going 12 and 3, multiply to 36 and add to 15. I feel good about that. So x plus 12, x, oh, I don't feel good yet. So what did I forget? X plus 12, x plus 3, divide by 2. Now I start to feel better. So 12 divided by 2 is x plus 6. 3 divided by 2 is a fraction, so slide the 2 in front. That's 2x plus 3. And then 5, the opposite number is the factor. Then the opposite numbers are the zeros. So that's negative 6. From here, the opposite number is negative 3 over 2. And the opposite number is 5. Let's try it again. So I give you a factor. So the opposite number, negative 8, 6, 35, negative 99, and 40. So the 6, 8 times 6, it's negative. That's negative 13. Ooh, 8 times 13, that's 80 and 24. Is that 104? Yes. And then 5, and that's negative 40. Look at that. Oh, wait. Oh, no. I'm going to finish it. So 6x squared minus 13x plus 5. First number times the last number, that's 30 and negative 13. So those two numbers are negative 10 and negative 3. So I'm going to write down negative 10 and negative 3, but not forget to divide by 6. They have to be reduced down. So divide by 2 to reduce it down. That's 5 over 3. Divide by 3, that's 1/2. And then we slide. So negative 8 is a 0. The opposite is a factor. Here, the opposite is 5/3. Here, the opposite is positive 1/2. And then I slide the denominator. So the 3 is going to slide in front. That's 3x minus 5. The 2 is going to slide in front. That's 2x minus 1. And you did it. All right. I'm going to have another video. Mr. G Math over now. Till next time.